Hey everyone, welcome back to another TxePrep video, and in this video we're going to be talking about the USACO 2019 January Contest Bronze Division problem number 3, Guess the Animal. So let's just start reading it, and if you want to skip me reading it and go straight to the analysis, you can do so. There'll be those timestamps on the video. So let's just start reading it. When bored of playing their usual shell game, Bessie the cow and her friend Elsie like to play another common game called Guess the Animal. Initially, Bessie thinks of some animal. Most of the time, this animal is a cow, making the game rather boring, but occasionally Bessie is creative and thinks of something else. Then Elsie proceeds to ask a series of questions to figure out what animal Bessie has selected. Each question asks whether the animal has some specific characteristic, and Bessie answers each question with yes or no. For example, Elsie asks, "Does the animal fly?" with which Bessie replies no, and then she asks, "Does the animal eat grass?" And then Bessie replies yes. Elsie asks, "Does the animal make milk?" Bessie replies yes. Elsie asks, "Does the animal go moo?" In which case Bessie says yes. And in that case she said, "I think the animal is a cow," and Bessie says correct. We can call the feasible set, if we call the feasible set of all animals with characteristics consistent with Elsie's question so far, then Elsie keeps asking questions until the feasible set only contains one animal, after which she announces that the animal is her answer. In each question, she picks a characteristic of some animal in the feasible set to ask about, even if this character might not help her narrow down the feasible set any further. She never asks about the same characteristic twice. Given all the animals that Bessie and Elsie know, as well as their characteristics, please determine the maximum number of yes answers that Elsie could possibly receive before she knows the right animal. The first line of input contains the number of animals, and each of the end lines describes an animal in which starts with an animal name and then an integer k with k characteristics about the animal. Animal names and characteristics are strings of up to 20 lowercase letters. No two animals have the exact same characteristics. Please output the maximum number of yes answers that Elsie could receive before the game ends. So this is our input, and that 3 would be our sample output. So let's look at this. So basically what we're trying to do is find the maximum number of similar traits between two animals. Like for example, bird and cow have no similar traits, while sheep and cow both have one similar trait of eats grass, and goat and cow have two similar traits of makes milk and eats grass. So what we're going to do is actually find the maximum number of similar traits and then add 1 to that, because we can say that Elsie's going to ask for makes milk and then she'll receive an answer of yes, but she doesn't know who it's going to be, whether it's a cow or a goat, and then she'll ask eats grass, and then she will still not know whether it's a cow or a goat, because there's 2 animals with that, or actually 3 animals with that, but in the end she will ask something like goes moo or is awesome, and then she'll be able to narrow it down. So we would see a total number of 3, which is exactly what we saw over here. So in order to do that, what we can do is put everything into a set. So we can for example combine. Let's say we want to combine cow and goat, since those are the 2 animals that would produce a correct answer. So a set for the cow would include eats grass, is awesome, makes milk, and goes moo, and an individual set for the goat would be makes milk and eats grass. So each of them would have a length of 4, and this would have a length of 2, right? But now what we're going to do is combine these sets. So when that ends up happening, we end up with a total of 6, because we end up with a set the size of 4, because makes milk already exists and eats grass already exists. So then the size of our set is 4, and in order to find out what is the maximum number of traits, we can do the size of cow and goats, the size of cow and goats set minus their combination. So 4 plus 2 minus 4, which is just going to be 2, and that would be the number of similar traits, and we can just add 1 to that to find our answer. So let's actually start programming this. So over here, I'm going to do include bits standard C++.h, and then using namespace standard if stream fin guess.in and offstream fout guess.out. And I have obviously set up the files over here. So here's guess.in with the input, and guess.out with nothing in it. And main, I don't know, but REPL does that, so it just puts a file there for you. It doesn't really do anything. It's not related to what we're doing here. So let's just continue. So we have our int n, and then I'm also going to make a vector of sets, because I'm going to have a vector of sets for every single, basically an array of sets for every single cow. So vector of set, and then in that it's going to have string and I'm gonna call this traits. So that's it. And then I can create the int main function, and I'm gonna input n, and then I'm going to resize traits. So traits dot resize. I'm gonna make it to a size of n. And then what I'm gonna do after that is I'm gonna create a for loop for in I is equal to 0, I is less than n, I plus plus. And in that I'm gonna just input the name. So string. Whoops. So here's our string name, and then also our integer k, which represents the number of traits that it has, as like over here. So this is an integer k. And then what I'm going to do after that is input name and then k. And actually name doesn't even matter because we're not outputting anything related to the name, so we can just ignore the name. So what I'm going to do now is for int j is equal to 0, j is less than k, j plus plus, and I'm just gonna add traits to the set that is in the vector for that specific animal. So I'm gonna say string s, and then we're gonna input that s because that is our trait, and then we can say traits of I dot insert s. So that is our that is just everything. That's all our input. So now what we're gonna do is find out the maximum same. So I'm gonna start off with 0, and then every single time we find something bigger, we're gonna obviously increase it. And now I'm gonna loop through every single animal. So for int I is equal to 0, I is less than n, I plus plus. For int j is equal to I plus 1, and make sure we don't want to have it j is equal to I, because then we would just get an answer. Like for example, we would get an answer of 5 in this case, because cow would be the same thing as cow, but we don't want to check if is the same animal is the same as itself, because that's irrelevant. So j is less than n and j plus plus. And now what we can do is create another set, and this is the set I was talking about, where we merge the characteristics of these two sets together. So what I'm going to do now is I'm going to say set string, and I'm just going to call it s, just like that. And then I'm going to merge the two sets of those animals. So I'm going to say traits. So in order for this, we have to do traits of I dot begin. So that's just an iterator. So traits of I dot n, and then after that we have to and then we have to put in the traits of j dot begin and traits of j dot n, and then we also need to have this thing called an inserter. And what I can do with that is just s, which is just what the set that we're looking to do, and where it goes. So set dot begin, and that's basically our merge function. And what we can do after that is we can calculate the int num same, or just same, is equal to traits of I dot size plus traits of j dot size minus s dot size. So like I talked about before, 4 minus 2 minus the size of their combined set, which would be 2, and that would be our same. So then what I can do is max same is equal to the maximum of same that we already have, and max same. And then after that I can just output max same plus 1, because that would help us find the total number of unique answers required. So max same plus 1, and then that would be our final answer. So let's try running this. So here's the input, and we should get an output of 3. Yep, we did get an output of 3. So now let's actually try submitting it. So here I am about to submit the file, and let's see what happens. It's still loading, but okay, so we see that it's starting to work, and actually it does work for all of them. So that means our solution works, and the way we did it was right. So just to reiterate what we did, basically we created an array of sets for every single animal for each of their traits, and then we input all of that, and then at the end, in order to calculate it, we looked at 2 animals, we compared 2 animals together, and we checked, we merged their sets together. And not only that, in order to calculate the number of same traits, what we did was we added this length of the individual sets and subtracted the size of the merged set in order to find the length, and just added the maximum of those and added that to 1 in order to find our answer. So that's basically this question. So I hope to see you guys in the next video.